So here we have the Bohr model of electron arrangement. And you can see that Bohr still kept the idea that in the center of the atom, what do we have in the center of the atom? The nucleus. And I would like you to tell your partner what particles are inside the nucleus. What particles are in there? Okay, what's one of the particles in the nucleus? Yes. Neutrons, yes. And the symbol for neutron is a lowercase n with a little 0 up at the top, okay? Pardon me? This is not going to be on the quiz on Monday. It's going to be something, it's just going to be on the models, the names, and the scientists, okay? All right. What's the other particle that's in the nucleus? Yes? Protons. And the symbol for proton, yes, sorry, it's a P with a plus. Now I would like to tell you to chat with your neighbor and see if you can figure out exactly why we put a 0 here and a plus here. Okay. Now, that's what's in the nucleus. What is outside of the nucleus? Electrons. And if we had to give a symbol for the electron, tell your partner what the symbol for the electron would be. Anyone want to tell me? Yes. It's an E with a minus because electrons have a negative charge. Now Rutherford said the nucleus is in the center, and then we have mostly empty space with some electrons just sort of floating about in it. He didn't know what the electrons were really doing. Bohr did some other experiments, which we are not going to talk about this year. If you are interested in how Bohr figured out this next step, there is some enriched material here, and if you want to help yourself to that later in the class, you may do so, okay? But what Bohr said, he said those electrons are not just randomly bobbling about outside the nucleus. They are actually living in these circles, these rings around the nucleus, and those are called electron shells, okay? The other word for shell is energy level. Now, to be honest, Bohr actually called them orbits, okay? But we don't call them orbits, we call them shells. Yes? Oh, this is on page 33. 33. No problemo. So, what he said is that he said that electrons live on rings at specific distances from the nucleus. And what is the name that we give those rings? We call those rings shells or energy levels. Orbits is that's what Bohr called them, but those are outdated. That's an outdated term now. So shells or energy levels. Now, when he said the electrons can live on those rings, that meant that if you had an electron, can it live in between the rings? Can it live in between shells? No, it's not allowed to be there. So electrons are not allowed in between the rings. They can only live in the shells, not between the shells. Only a certain number of electrons can live on each shell. There's a maximum. And you're going to think back, see if you can remember from last year how many can live on the first shell maximum. And then once you've thought of that, you're going to think about the second shell and the third shell. It goes 2, and then 8, and then 8. And if you have trouble remembering that, here's one way you can remember it, because this is actually why it works. How many elements are in the first row of the periodic table? 2. How many elements are in the second row of the periodic table? 8. And how many are in the third row of the periodic table? 8. Okay, so 2 maximum in the first shell, 8 maximum in the second shell, 8 maximum in the third shell. Yes, you can. Those are just maximum numbers. So if you needed 6 electrons, there would be 2 on the first shell, and the other 4 would be on the second shell, and there would just be some empty space in there that could hold electrons that doesn't. Okay? Now, the Bohr model really only works up to and including element number 20, which is calcium. And then after that, we hit this middle block here. You guys remember the name of these elements in the middle? They're called the transition metals. The transition metals don't do well with the Bohr model. The Bohr model and the transition metals don't mix. You remember how the Bohr model is not really accurate? Okay? It becomes really inaccurate when we talk about the transition metals. So I will never have you draw a Bohr model past calcium. Okay? Besides which, who wants to draw more than 20 electrons, right? So there needs to be a stopping place. So we're going to stop at element number 20 for Bohr models. Okay. So electrons are negative, and the nucleus is positive. So if I had my nucleus here, and I had an electron, and it had a choice between being on shell number 1 or being on shell number 2, in being in location A or location B, where would the electron prefer to be, and why? Yes? Yeah, it would prefer to be closer to the nucleus in shell number 1 because it is attracted to the nucleus. That negative electron is attracted to the positive nucleus. So the electron prefers to be in shell 1, closer to the nucleus, because the positive nucleus attracts the negative electron. So if you give an electron a choice, it's going to go into shell number 1. If you give another electron a choice, it's also going to go into shell number 1. But now you have 2 electrons in shell number 1. And what happens when you get to 2 electrons in shell number 1? Shell number 1 is full, okay? So you can think of it like this. In the atom, we have shell number 1, and you can think that it's as though this is like a little hotel, okay? And shell number 1 is like floor number 1, and there is one room. And that room has space for 2 electrons in it. Every room can hold maximum 2 electrons. So electron number 1, where's it going to go? It's going to go in that room, okay, on shell number 1. And you can imagine that this hotel, there's no elevator. Yes? Where would you like to be if you had a bunch of luggage and no elevator? You want to be on the first floor or the second floor? First floor, yes? Okay. So along comes electron number 2. Where is it going to go? It's going to go right beside it because it's like, I don't want to walk up those extra stairs. Okay. Chat with your neighbor. How many rooms are there on the on the second floor? And each room holds 2 electrons. There's 4 rooms, yes? So we have 1 room, 2 rooms, 3 rooms, and 4 rooms. Now, once I've got my first 2 electrons in, where is the third electron going to go? Is it going to go on shell number 2 or is it going to go on shell number 3? I've drawn a terrible circle. That's an awful circle. I'm going to try again. Shell number 3 also has 1, 2, 3, 4 rooms. Is the next electron going to prefer to be on the second floor or the third floor? Second floor, because does it want to walk up those stairs? No. That's our analogy, but really being on the second shell gets it closer to the nucleus, which is where that negative charge wants to be, okay? So here comes our third electron. Now, the electrons do not know each other, okay? They're strangers. If you were another electron coming in, and you're like, that little electron in that room right here, I don't know that electron, where would this one coming in prefer to go? Well, it's not going to go on the third floor yet because there's still rooms available on the second floor. But where is it going to go? Is it going to go in the same room or a different room? It's going to go in a different room. Now, the scientific explanation for this is that electrons, they're both negative. What does negative do to negative? It repels. So would the electrons rather be in the same room or further apart from one another? Further apart, okay? And technically further apart would be top and bottom, but this is not a perfect model. And I find it's easier if people just always go around in the same direction every time, then they don't make as many mistakes. So we go around just like a clock. Okay, so we go top, right, bottom, left. And then we go around again. Top, right, bottom, left. I would like you guys to move your hand with me. Top, right, bottom, left. Top, right, bottom, left. And once you've done that, you have 2 electrons in each orbital. You'll have to move to the next, their third shell, and then you will go top, right, bottom, left, top, right, bottom, left. Is good? Okay, so where is my next electron going to go on my second floor? I'm bringing in a 4th electron. Where's it going to go? On the bottom. And then the next one on the left. Do I still have room on the second shell? Yes, because I only have 4 electrons and it can hold 8. Where is my next electron going to go? It's going to go on the top. It's going to share a room, okay? And then it will pair off. So again, I go top, and then where do we go next? Right, and then bottom, and then left. Who's a good teacher? My left is here. Like left. Hard to remember sometimes. Once you have those 8 electrons, it's full. Yes? Where does the next electron go? 3rd floor. Now, does my next electron go there? Why not? What's wrong with that little red electron? Stranger danger, yes. It doesn't want to be in the same room unless it has to be. Unless it's like, oh my gosh, I have to trudge up another floor of stairs, right? Then it'll be like, okay, fine, I'll share, right? But no, it would prefer to have its own room. Oh, I knew that was going to happen. It erased everything for me. There we go. So instead of going in the same room, it will go to the right. And I would like you guys to point to tell me where the next electron goes. Yep. And then the next one. And then the next one. Next. 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 How many electrons do we have in total now? We have 18. We've got 2 and 8 is 10 plus 8 is 18 electrons. I would like you to go look at your periodic table And I would like you to guess which element we have drawn. Go look at your periodic table. We have 18 electrons. Which element do you think we have? We have argon, because guess what? The number at the top here, if we look at our little doodad in the middle, 14, whoa, not supposed to scribble, 14 is what we call the atomic number. Do you guys know what the atomic number tells us about an atom? It tells you how many protons. It tells you the number of protons. If you want to write that on your sheet, you can. Okay? Now, in a neutral atom, what, yes. Yeah, I would. So if you're like, how many protons are in argon? You'll be like, oh, it's 18 because it's got an atomic number of 18. How many protons are in silicon, the one that's given to us right here? How many protons? 14. Now, let's say I have silicon. This part, don't write this down, the stuff in red, okay? If I have 14 protons and I have a neutral atom, how many electrons will I have? What's the charge of something that is neutral? If something is neutral, that means its charge is 0. And if I have 14 positive things, how am I going to make it equal 0 charge? I need 14 negative things. So in a neutral atom, if you have 14 protons, you must also have 14 electrons to balance the positive charge, okay? And until we get to section 2.5, which is not for quite a while, all of our atoms will be neutral. So for now, you can say the number of protons is equal to the number of electrons, okay? So in a neutral atom, and this part you can write down, the number of electrons is equal to the number of protons. Those two are the same because you need to have the same amount of negative as you do positive. So if I said to you, how many electrons in a neutral atom of boron? How many electrons in a neutral atom of boron? 5. How many protons in a neutral atom of boron? 5. Let's get fancy, shall we? How many protons in a neutral atom of lead, Pb? 82. Now, if you're like, oh my gosh, how am I ever going to find lead? Lead's hard to find, right? It's like hiding in the middle. It's not LD, it's Pb. You can use the back side of your periodic table, and it's got them listed alphabetically. Ooh, fancy, yes? So you can be like lead. Lead starts with L. So let's go down to where L is. Here's lead. And in this column, you have the atomic number. It tells you it's number 82. Isn't that nice? So if you have trouble finding an element on the front, you can always go to the back and look up it alphabetically, okay? So please tell me how many electrons in a neutral atom of calcium? Calcium. $20, yes? So let's go back here. And right now, we have 18 electrons. What if I wanted to have calcium, though? What would I need to do? I would need to erase this because I don't have enough room, right? And then what would I need to do? Calcium has 20 electrons. This structure here has only 18. How could I fix that? I could add another shell. You can keep adding shells up to 7 because then we run out of elements. Okay? Now, like I said though, the Bohr model falls apart when we get to element number 20, which is calcium. So technically, we have maximum in our first shell. What's the maximum? In the second shell, what's the maximum? 8. In the third shell, what's the maximum? 8. And in the fourth shell, sometimes you'll see people write the number 18. But I'm going to put a little star beside that because really, if you're drawing 18 electrons in the fourth shell, it's just a mess. Yes, it becomes really nasty and like you're like, where do I put them? They can't go top, bottom, left, right. So we just stop when we get to 2 rooms, okay? Even though there's more rooms on the fourth shell, we just don't worry about them, okay? So my fourth shell would look like this. I would have a room here, I would have a room here, and then I would have some other rooms hanging out. Okay, more rooms, but we're not going to worry about them. We're just going to ignore them. Okay, so we're going to ignore the other rooms on the fourth floor because if I have 18 electrons, where is number 19 going to go? At the top. And where's number 20 going to go? At the right. And am I ever going to give you 21 electrons? Am I ever going to give you 40 electrons to draw a Bohr model? No. Okay? So basically, you only have to draw up to calcium, and that's it. And so you don't have to worry about these rooms down here. That was fun. All right. So let's take a look at, so here's lithium. You'll notice we have 1, 2, and then the third one goes on the second shell. This is page 33. And tell me the atomic number of lithium. How do you know it's 3? Because there are 3 protons. You could also look it up on the periodic table. Let's take a look. Actually, don't flip your page. Don't flip your page. Where is it? Oh. Actually, you can flip your page. It's fine. Here we have nitrogen. This is page 34. Page 34. Here's nitrogen. It is atomic number 7. What does that tell you? It tells you that there are 7 protons. It also tells you that there are 7 electrons. And guess how many? Well, let's count them up. 1, 2. If I were drawing them in, where would I draw the third one? 3, why is this not working? Please work with me, little pen. 3, where's 4? 4. On my pen, stop. 4, 5, 6, and 7. Okay? And so here's just a little model with the first floor, the second floor, the third floor, and then of course our fourth floor, we only worry about 2 of the rooms, but it actually has lots more. And here's oxygen. It goes in order 1. Our second one goes here. Our third electron goes here. The fourth electron goes on the right. Number 5 goes at the bottom. Number 6 goes at the left. And then number 7 goes at the top. And number 8 goes on the right. Is good? You're never going to have to actually draw the numbers when you're like writing a quiz or anything like that. And by the way, the Bohr model, like drawing with the electrons, is not on the quiz on Monday. It's just being able to say, okay, I have the nucleus and I have the electrons on the shells. Okay. That's the whole thing with the like numbers of where each electron goes. Number 1 goes here. Number 2 goes here. And then goes 3, 4, 5, 6, 7, 8, 9, 10, and around you go twice, and then around you go twice, and that's it. And you guys are now going to work on pages 36 to 38, and that is your homework, and I will come around and check on you and see how you're doing with those. Okay, let me know if you have any questions. 36 to 38, I think. Let me just double check. That's page 36. Yes, 36 to 38. 37, 38. Yep, that's it. Yes, I'll grab you one. Yeah. Number of Uh-oh.